That's 2.4, limits and continuity. We are going to basically discuss breaks in graphs. I want to give you kind of a conceptual understanding of continuity, and then we'll go into the definition, which involves limits. We'll look at some types of continuities, one-sided continuities, and then we'll probably stop there for the day because it's a pretty long section. We have 2 days, so this will be part A. If I have a graph, at some c, here we have f of c, and this is a function. Okay, f of x is continuous at x equals c. Okay. Basically, what we say in calculus is you don't pick your pencil up. Right, so I can draw this whole entire graph without picking my pencil up. It's continuous. Okay, so this is continuous at a point. We can have intervals. Okay, f of x can be continuous on an interval, closed or open. All right. And that would mean from A to B, you never pick your pencil up. There are a lot of discontinuities. We're going to investigate just the basic types. The first one I like to show people is that. It's called a removable discontinuity. It's just the point. You can have one up here, still discontinuous because you have to pick up your pencil when you pass that hole. All kinds of So this is a removable. Discontinuity. We have other types. Where the graph might jump. It's called a jump discontinuity. We also have an asymptote. Okay, obviously they're not continuous. This is called an infinite discontinuity. All right, so several different types of discontinuities. We can have discontinuities from the left and from the right, and we'll tell you about that here in a minute, but I want to get the definition down on paper. It involves limits. Okay, we must assume f of x is defined on an open interval containing x equals c. F is continuous at x equals c if the limit as x approaches c of f of x equals f of c. So what we're saying is, go back to one of our original picture, the limit has to exist. So from the right and from the left, it has to approach the same spot. And this point has to exist. And those two have to be equal to each other. Okay, so we're saying three things. We're saying the limit exists, so we know that it approaches the same spot from both sides. Okay. F of c is defined, meaning as a solid point. Okay, this would violate. That one wouldn't. None of these violated, actually. And then the most important part, they are equal. Okay, so you have to have the limit existing as we approach c. C has to exist, and those two values have to be equal. Let's say this one here violates it because they are not equal. The limit exists. C is defined. F of c is defined, but they are not equal. Okay. And again, any one of those discontinuities that you see, you can go through and use this definition of continuity or a continuous function. Okay. Let's say an example. What if we have that function? So is this continuous? Sometimes we don't define an interval, it means forever. Okay. It would be on the interval negative infinity to infinity. So we have to show that the limit as x approaches c of f of x equals f of c. Right. So if we write that, every y value for that graph, so if I graphed it, 1, 2, 3, 4, there's this graph. Every single y value is 4. So any limit, any x value that I approach, the y value is going to be 4. So any f of c is going to be 4 as well. So we know that this exists, this is defined, and they are equal. Okay. Therefore, f of x is continuous. So we would write the limit exists f of c is defined, and they are equal, so f of x is continuous. Right? Bam. Okay. What if we have something like g of x equals x to the 4th? So we have to show
again, get this definition in your head because you have to have it memorized. So again, I taught you the first thing to do is plug the value in. Okay, so we know that that limit exists. Okay, what does f of c equal? Well, plug c in for x. Okay, it's defined. And we know they're equal. It's because we've shown that. So we can, again, make another statement. The limit exists, f of c is defined, and they are equal, so f of x is continuous. Okay, a different way to show it. All right. Let's look at one-sided limits. Okay, or sorry. Those are one-sided continuities. We've already gone over one-sided limits. A function f of x. I almost didn't capitalize that. Is called, and we're going to say, left continuous. If at x equals c, if the limit as x approaches c from the left of f of x equals f of c. So that would have to be something of this nature. Left continuous, because the limit approaches f of c, which exists. This one is not right continuous because f of c is different. Okay. F of c is here. The limit from the right is here, so it's not right continuous. Okay, so let's look at right continuous at x equals c. If the limit as x approaches c from the right of f of x equals f of c. Okay. Let's give you a piecewise function. Let's make that less than 1, 3 if 1 x 3 x 4. So we're going to take this function, y-intercept is 0, slope is 1, but we're only going to define it for less than 1. And it's open because that's strictly less than. Okay, from 1 to 3, so from 1 to 3, it's 1. The function is the value of 3, and it's equals, so solid, solid, and then from here. Okay. The limit as x approaches 1 from the left of f, capital F of x, equals 1. F of 1 equals 2. Or, sorry, 3. 1, 2, 3, because that's the solid dot. The limit from the left is 1, 3, so this is not left continuous. The limit as x approaches 1 from the right is 3, so we're coming here. F of 1 is 3. Okay. It's right continuous. Okay, we can say that f is continuous at x equals 3. It's here because from the left, from the right, and the point exists. Okay. Last thing. Function continuity. These are just general function is. Okay, so that's continuous. That's a root function. So that'd be like if n is 2, it'd be a square root. If n is a natural number. Okay, those are continuous. Y equals b to the x is continuous if b is greater than 0 and not equal to 1. Okay. And lastly, the log is continuous for x greater than 0, b greater than 0, b not equal to 1. Okay. Just general functions that are continuous. Okay, this is the work for A. We'll work on it Tuesday. Okay. Probably be due Wednesday. We split this section up pretty heartily into 2 sections, so have a good weekend.